আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম সালাম। সবাই ভালো আছো?
জি স্যার, আলহামদুলিল্লাহ।
ওকে, দ্যাটস ফাইন।
নমস্কার স্যার।
হ্যাঁ, নমস্কার। Okay, we can start now. I think we are now 15 participants. Okay, our online lesson will be on environmental chemistry. Okay, in this course actually we have this course content. I will teach you redox process in aquatic environment, environmental sampling and monitoring techniques, and another chapter is marine pollution. These three chapters will be taught by me. Okay, today we will talk about the redox process in aquatic environment. So before going that, uh, we need to know what is environmental chemistry actually. Uh, because already you studied environmental chemistry in first year as well as in second year. Environmental chemistry, that means the chemistry of the environment, or environmental chemistry may be defined as the study of the sources, reactions, transport, effects, and fates of chemical species in the hydrosphere, the atmosphere, the geosphere, and the atmosphere, and the effects of human activities. They are all can use the annotate. Okay, so from this we can understand actually that means it's a chemistry. Okay, chemistry of in our environment. Environment is total environment from atmosphere to geosphere, everything. It covers everything surrounding all of us. For an example, that means here one thing is important. This actually deal with the chemical species, the source, transportation, and their ultimate fate. Hmm. For an example, here I will give an example how actually this work. Here in this figure, you can see the coal conversion. During coal conversion, is produced sulfur dioxide. This is a pollutant, you know that. And this sulfur dioxide is transported to the atmosphere through the fume. Okay, and in the atmosphere, it's oxidized. Is oxidized into sulfuric acid. Okay, and this sulfuric acid again run off by rain, acid rain, as a acid rain, and which is detrimental to the plant as well as the aquatic life and so on. So it's come to the here again precipitate as a sulfuric acid, and then it can be dissolved, or it can stored in the aquatic part or in the oceans or the wetland body, water body, or it can be deposited as a sulfate salt, precipitated as a sulfate salt, ultimate phase. Okay, so you can see from here the ultimate fate of the sulfur dioxide. Okay, it's come from the actually human activities primarily combustion process, and the final fate or is the solution in the ocean or deposit as a sulfate salt. So this chemistry, how it's this is the source and this is actually transportation. It's go to the atmosphere, and from atmosphere is actually there's a reaction, photosynthesis reaction and oxidation reaction, converted to sulfuric acid, and again it's come here, land and aquatic environment is come here. So you can see source, transportation, and final fate is the deposit into the ocean, or is the dissolve in the water, aquatic environment or water. This is the ultimate fate. So this thing actually dealt in the environmental chemistry. Okay, just give an idea. What does environmental chemistry mean? So it's actually deal with the sources, reactions, transportation, and effects. You can see effects actually. This is a sulfuric acid rain. You know the effects of acid rain is detrimental. It's toxic to the plant as well as life, as well as the fate. That means ultimate fate. Ultimate fate is here. Okay, this sulfur dioxide is this will come here and here is dissolved in ocean, water, or deposit or precipitate as a sulfur salt. So this is the actually typical example of environmental chemistry. Well, fun, I think you know what is environmental chemistry now. Okay. But today we will talk about the redox processes in aquatic environment. It's one of the topic of environmental chemistry, our course. Before going that, I think here you know the redox process. That means this is actually a reaction, one type of chemical reactions. You know aquatic means actually water, and environment. So fundamentals we have to know the fundamentals of aquatic chemistry, because in environmental chemistry is deal with also species, chemical species as well as the chemical reactions. So in aquatic environment, you know that the most important element is the water, and already you know the importance of water. It's very known to you what is water. Throughout history, the quality and quantity of water available to humans have been vital factors in determining their well-being. Okay, you know that because it's also taught that water is one of the fundamental pillar for life. It's one of the fundamental pillar of life in this planet, Earth. Okay, so in aquatic chemistry, actually aquatic chemistry which deals with the chemical phenomena in water. So it actually considers a lot of stuff. You can see the surface water, as well as the groundwater, and also ocean, and what is going on there. What's chemical reactions going on this water body, and what's the fate of these chemical species, and how could they transfer or transport from one sphere to another sphere, and that means atmosphere to hydrosphere to lithosphere or geosphere, so on. Okay, we will deal about this. And the study of water is known as hydrology, and it is divided into different subcategories. Limnology, this is one of the branch of hydrology which actually deal with the characteristic of fresh water, including biological properties as well as chemical and physical properties. That means in the branch of limnology, actually it's deal with the science which is actually related to the fresh water as well as physical, chemical, and biological properties. And we also know oceanography actually is the, some people call it the blue science or so on. This is the science of the oceans and the physical, chemical, and biological properties involved in the ocean. Okay, fine. Here, so we are talking about the aquatic chemistry. We must understand the water from its molecular structure as well as its source. Okay, we must know what is actually water. What is, you know that water is very common to us. Uh, So sources and uses of water. This is, there is a hydrological cycle you can see here. Hmm. Sources and uses of water here, hydrological cycle with quantities of water in trillion of liters per day. Uh, the world's water supply is found in the 5 parts of the hydrological cycle. 5 parts. The first one, the world's water, uh, mostly 97% of the earth water is found in the ocean here. Okay, you know that 97% of the water is also saline due to the, this is actually ocean water, here saline. And then another fraction is present at water vapor in the atmosphere here. Atmosphere, you know that in the cloud form. Hmm. And water is a significant molecules. It can it can exist both in solid form, liquid form, as well as in the gaseous form, which we call the vapor. So you can see here in ocean, we can find is a liquid form of the water, and this is 97% of the earth water. And then we can find water here in this vapor form or gaseous form in the air as a cloud. And some water is also contained in the solid state in ice, snow, snowpacks, glacier, and polar ice cap. Here, this water, you know that glacier, ice glacier, polar, and snowpack. This is actually ice. It's a solid form of the water. And we have the surface water actually, which usually we use for our domestic purposes and irrigation and so on. We have lake and reservoir. Okay, we have this thing, stream and reservoir is actually surface water. And then finally we have the groundwater actually, which is actually located in aquifers underground. And we usually use this surface water and groundwater for our domestic purposes as well as for even industrial purposes as well as for drinking purposes and so on. So this is the five parts of hydrological cycle, and you can see here actually the transportation. In daily, you can see from the ocean uh, around 1,164 trillion of water is go evaporation here, and then from it's come as a precipitation, that means as a rain, it's come down around more than 1,000 liters per day precipitate, and the remaining one actually movement of water vapor to land. And here again, it's also here you can see from lake and reservoir, particularly surface water as well as from the plant. Okay, plant also for transpiration is called. The water or water vapor comes from the plant is the process called transpiration. And from surface water is come out as a evaporation. It's 195 trillion of what trillions of liter. And these two again come as a precipitate. It's precipitate here. Here again, it's come to the infiltration into the groundwater, and groundwater there is also transportation. So you can see this is the hydrological cycle. Okay, how it's move, transport, and the source of water. Well, fine. It's very simple, and I think already this stuff how water is actually open and transportation throughout the sphere. And this is the important thing as a chemist, that water is a unique substance in this planet, and maybe even in the universe. Where is it unique? It has very, very some unique properties which actually important for the survival of life in this planet Earth. Here in this figure, you can see one of the important chemistry of water is that they can form hydrogen bond. And somebody even thought that hydrogen bond also is important for the evolving life. Mm. It's one of the important chemistry, one of the important chemical bonds that actually give facilitate the survival of life. You can find here hydrogen bond in the water as well as we can find hydrogen bond in the DNA. Okay, which is taught as the unique of life. Okay, here you can see hydrogen bond, and hydrogen bonds form between the water molecules. Okay, as well as this hydrogen bond can form even the solute molecules. Okay, and due to this hydrogen, I think you already know what is hydrogen bonds and so on. And because you can see in the hydrogen water molecular, I think we heard a background noise. One. Uh, it's better if you keep your microphone mute. Well, here I think you know already this structure of water is not actually is it a molecule. Water molecules actually consist of one oxygen atom and two hydrogen atom, and this is not actually linear structure like carbon dioxide. You can see it's a V shape, and the angle contra this angle actually 105 degrees Celsius. 105 degree. This angle, not Celsius, 105-degree this angle. And here oxygen is actually partially negative charge scale, partially negative charge, and hydrogen partially positive charge. And due to this is from a hydrogen bond among the water molecules. So water can exist as a lump with a huge amount of group together. As well as due to these properties, it also form hydrogen bond with solute. So it is actually an excellent solvent. Due to this structure, it's also bipolar structure. Due to this bipolarity, water is an excellent solvent. Okay, so you can see its unique properties, important property, excellent solvent, and why it's important: transport of nutrients and waste product, making biological processes possible in aqueous medium. Okay, as it can dissolve or it can dissolve so many solutes is important for transport of nutrients as well as the waste product, and it's make the live biological process possible in aqueous medium. The second one, highest dielectric constant of any common liquid. Highest dielectric constant because the bipolar nature, highest. High solubility of ionic substance and their ionization in solution. Due to this bipolar nature, highest bipolar nature, it's it's actually soluble most of the ionic substances. Okay, and higher surface tension than any other liquid. It has higher surface tension. I think you know this surface tension of water, and this due to this controlling factor in physiology. You know that in our body, actually, this surface tension is important as well as in aquatic environment and other for living of other microbes and so on. Governs drop and surface phenomenon. Okay, due to surface tension, you know that rainwater becomes like a round and so on and transparent to visible and longer wavelength fraction of ultraviolet light is the transparent. So due to this transparency, light, solar sunlight can go into the depth, too much depth into the water body. Particularly, this is actually beneficial in ocean. You know that in ocean there are a lot of microorganisms live who need the actually solar energy. So due to this transparency, this solar sound radiation can pass higher distance in the aquatic environment. Maximum density as a liquid at 4 degrees Celsius. I think you know this thing, maximum density. Water is above its freezing point. Water actually shows its maximum density. That's why we know that ice floats over the water. And this, due to this property, there is actually vertical circulation. And even in the, you know that in Antarctica and so on, where is that there is ice form and so on. Inside bottom of the ice there is water, so that their aquatic life can survive or thrive. Higher heat of evaporation than any other material. Okay, higher heat of evaporation. Uh, I think this higher heat, you know, that is actually in quantities around 2500 joule per gram. So here's higher heat of evaporation. It determines transfer of heat and water molecules between the atmosphere and bodies of water. Okay, higher heat, latent heat of fusion of any common liquid. Okay, so higher latent heat of fusion. So for fusion, you know that for fusion is the most huge amount of heat energy. So temperature established at the freezing point of water. So is actually significant. That's why we have some benefit. Higher heat capacity than any other liquid except the liquid air, ammonia, due to this stabilization of temperature of organism and geographical regions. So this all this property of water is actually beneficial for the survival of the life in this planet. Okay, then we will see what's happened there. Characteristic of bodies of water. Here you can see this is like a stratification of a lake. In Bengali, maybe lake character store business. You can see the reactions because in this chapter we talk about the reactions in aquatic chemistry. Okay, particularly the redox reaction. Here you can see what's going on there. There is actually two layers, epilibnion and hypolibnion. Epilibnion is the actually upper surface layer of this body of water, and here you can see the exchange of gases, right? Because this is the atmosphere and this is the actual hydrosphere water. So in this here we could expect that there is exchange of oxygen and carbon dioxide gases, okay, in the epilibnion. And here in the epilibnion, here due to is and it has the actually lower density compared to the bottom layer. This is the upper layer. Hmm. Here in upper layer we have a lot of algae, which actually using carbon dioxide and the solar sunlight radiation, they go for photosynthesis and produce the oxygen. Okay, so in this region, actually upper layer, epilymnion, which is called technically, relatively high dissolved oxygen because here algae producing using carbon dioxide and sunlight algae is producing lot of oxygen. So in this layer we have high amount of dissolved oxygen and chemical species is in actually oxidized form because availability of huge amount of oxygen. But here in the bottom layer, actually this is the actual interface between these two layers. Interface layer, intermediate layer is called thermocline interface. Here is actually hypolibnion. That means here what happened there? Here we can expect that there is a relatively low dissolved oxygen chemical species in reduced form. Why there is relatively low dissolved oxygen? One of the reason is that in that region there are some micro bacteria that decompose the materials, biomass, and so on. And by decomposing, they actually use the oxygen for decomposing the material by degradation. So in that layer, bottom layer, we have lower amount of oxygen. So chemical species present in this layer, actually there is in reduced form. So here you can see here is the oxidized form, here is a reduced form. This is the like the redox reaction, oxidation, reduction, and so on. So here is this. So we could expect that the chemistry of this layer, upper layer and bottom layer should be different. The chemistry as well as the biological process is different. Okay. During summer this happen, but in autumn and spring, thermoclinically, that means here we could have a temperature difference. Here actually higher temperature during summer, we kept here higher temperature and here is a lower temperature. But during spring, so we have a temperature difference here. But in spring or autumn, actually there is no difference. It become like a single temperature. So this behave like a unit, hydrological unit. There is actually no layer. So in that case, actually the chemistry as well as the biological process is different. It changes. Okay. So this is actually important here how it's behaved. So in actually in a lab, the upper layer is actually you can see this type of reaction photosynthesis going on, and here bottom biodegradation, which actually utilize oxygen, dissolve oxygen. So here all species remain reduced form, but in the upper layer we have the actually here higher amount of oxygen, and chemical species is in oxidized form. Okay, now we will see what type of actually chemistry exists in aquatic environment. Okay, here all type of chemistry already you know this. You are familiar of types of chemistry. Aquatic environmental chemical phenomena involve processes familiar to chemists, including acid base. You can see this is acid base reaction. Solubility, you know this solubility. Oxidation reduction, which is actually called redox reaction, and complexation reaction. This type of reaction involved in aquatic chemistry, and this is very familiar to chemistry and so on. The important thing is that there are actually a lot of reactions. Here you can see again gas exchange with the atmosphere is actually this is a hydrosphere and this is the atmosphere. There is exchange in this surface interface exchange, and here is actually redox reaction. You can see ammonium ion to nitrate ion is a redox reaction. This is the complexation, chelation or chelating agent using the heavy metal ion complexation here. And this is photosynthesis. Actually, you know this photosynthesis. And by photosynthesis from bicarbonate ion, we have the carbonate ion. Okay, carbonate ions. And carbonate ions undergo acid-base reaction. By acid-base reaction is produced by carbonate ion and hydroxyl ion. Again, these carbonate ions goes for precipitation. And it reacts with the calcium ion and is from the calcium carbonate as a solid formula. So it's precipitated, deposited. And here also microbial actions. You can see sulfate ion and this is produces hydrogen sulfide or water and also carbon dioxide. So all this reaction chemistry actually involved here. And here also you can see leasing. If there is some sediment here, you can see leasing is also the uptake of the some even gases and so on. Also, this stuff. So this is actually important. In from all these reactions, we particularly focus on the this one because in our chapter we'll talk about the redox processes in aquatic environment. Okay, we also have other photosynthesis, acid-base, precipitation, complexation, microbial reduction, and so on. First, we only focus on this stuff, reduction and oxidation. For your convenience, তোমাদের understanding এর সুবিধার জন্য আমি হয়তো initially I will talk some about the acid-base, precipitation, and so on. Just give an idea. Okay, fine. Here, first, because here we have these gas exchanges here, because this is also important. You know that dissolved oxygen and so on, also carbon dioxide level is important for survival of aquatic lives. Okay, so we can see first gases in water. I will go faster because this is actually just give an idea what's going on in aquatic environment. So first of all is a dissolved gases, oxygen, which is important for fish, and carbon dioxide, which actually photosynthetic for algae, are crucial to the welfare of living species in water. Okay. Some gases in water can also cause problems, such as the death of fish from bubbles of nitrogen formed in the blood caused by exposure to water supersaturated with nitrogen. Okay. That means we must have different, we have an optimum level of gases. We need the oxygen, but too much oxygen is not good. Also, we need also carbon dioxide. Even you can see if we have some poisonous gas and nitrogen, if the aquatic life live in a supersaturated aquatic environment with nitrogen, then they have actually, due to diffusion, some nitrogen actually goes into their blood and then they're dead. Okay. The solubilities of gases in water are calculated with Henry's law. I think already you studied this thing in physical chemistry. Okay, because gas exists in water, there is some sorts of chemistry. Actually, the solubility is important. And Henry's law actually, you know this thing is practical application. তোমরা যে সফট ড্রিঙ্ক গুলো ইউজ করে আমরা we know that soft drink, Coca-Cola, Pepsi, they use carbon dioxide. The amount of carbon dioxide remain in the soft drink is actually is follow this Henry's law. Okay. Here, which state that the solubility of a gas in a liquid is proportional to the partial pressure of that gas in contact with that liquid. Okay, is actually how much solubility of a gas in the liquid is depend on the partial pressure of that gas in contact with that liquid. Is the Henry's law. In physical chemistry, you will learn more about this. It has also practical application in actually soft drink industry, Coca-Cola, Pepsi, and so on. Well, sorry. Then again, oxygen in water. We call it an without an appreciable level of dissolved oxygen. DO is called actually known as dissolved oxygen. Many kinds of aquatic organism cannot exist in water. Okay, you know that dissolved oxygen is important for aquatic organism. Many organism actually who need oxygen for survival, but some organism they don't need oxygen for survival. Aerobic and anaerobic organism, I think you know that. Dissolved oxygen is consumed by the degradation of organic matter in water. Okay, this dissolved oxygen is also important for microbial degradation of organic matter in water. Okay, if organic matter of biological origin is represented by the formula CH2O, this is a general formula. Organic matter is a, you know, this is a hydrocarbon like, also oxygen is present here, carbon, hydrogen, oxygen. It's a general formula. The consumption of oxygen in water by the degradation of organic matter may be expressed by the following reaction. It's just a reaction. This is organic matter is a general formula. Oxygen is needed here. Oxygen, you can see carbon dioxide and water is formed. For it is actually degradation. You know, okay, here, and then we have the water acidity and carbon dioxide in water. Okay, this is actually acid-base phenomenon. You know the carbon dioxide gases, as I talked earlier, the solubility of carbon dioxide in aqueous environment or actually in water. Acid-base phenomena in water involve loss and acceptance of hydrogen, plutonium ion. I think it is the definition of acid-base. You know, many species act as acids in water by releasing hydrogen ion while other excess base is biaxial hydrogen ion. Okay. And the water molecule itself does both. You know, the water is both acid and base. It's very simple. Already you studied this thing. An important species in the acid-base chemistry of water is bicarbonate ion. Okay, because it actually works as a buffer system. I think you also studied buffer and so on. So which may act either as an acid or base. Yeah? Bicarbonate ion is the carbonate ion and proton, and again is accept proton and then carbon dioxide and water. Okay, so here it is the acid reduce is dissolved for give of high plutonium ion. It accepts here, so it acts as both. It also acts as a buffer, and it has an important in the chemistry of water. Also, we know that in water there are also some strong acid, also known as mineral acid, free mineral acids, such as sulfuric acid and HCl. It actually acts as a pollutant for the water and so on. I think you know that for this thing. Okay, this is just know that acid-base reaction also happen. It's also happen in the water environment. Here, water is again this thing here. The carbon dioxide, actually the most important weak acid in water is carbon dioxide. Because of the presence of carbon dioxide in air and its production from microbial decay of organic matter, dissolved carbon dioxide is present in both soil or natural water and wastewater. So because you know that water actually is in touch with the atmosphere. In atmosphere we have the carbon dioxide is actually 0.039 volume percentage, where the oxygen amount is 21% by volume of dry air. You know that. So there is come from the atmosphere by exchange as well as the production from microbial decay of organic matter. Okay. Here you can see carbon dioxide, water and carbon dioxide atmosphere. The exchange. Okay. From atmosphere it can go into the water, and again it can go into the atmosphere. And this actually solubility. This is actually solubility which is controlled by Henry's law. How much is dissolved? It will depend on the partial pressure. And the equilibrium bicarbonate ion in between aquatic solutions and solid carbonate minerals. This one actually, you can see this stuff here. Okay, this is actually the chemistry of carbon dioxide, how it's come from into water body. Again, here a large share of carbon dioxide found in water is a product of the breakdown of organic matter by bacteria. Even algae, which utilize carbon dioxide in photosynthesis, produce it through their metabolic processes in the absence of light. Okay, so carbon dioxide in water body, carbon dioxide come from the atmosphere as well as come from the uh, microbial decay of organic matter, as well as some amount of come from the actual algae due to from their metabolic processes. Okay. Okay, here we can see the acidity and carbon dioxide in water. It's actually called the system carbon dioxide bicarbonate ion and carbonate ion system in water, which may be described by this equation. Carbon dioxide aqueous and water is behave like this reaction. Okay, bicarbonate ion and proton, and you can see the Ka and Pk value is like for acidity extent is actually indicate the extent of acidity and so on. It's very common to you. And here, this is the important thing. The predominant species formed by carbon dioxide dissolved in water is depend upon pH. Actually, who is one, whether it's carbon dioxide or bicarbonate or carbonate, is exist in the aquatic environment is depend on the pH. So this relation, how quantity, quantity exists in aquatic environment is depend on the pH of that water body. So you can see here in lower pH level, carbon dioxide is more prominent. Okay, fraction as this. Okay, is a fraction. You can see fixation or so on here. Below say 7, but 7 to or above 6 to a 9. Here you can see 7 to 9. Here bicarbonate is actually the neutral condition. Even bicarbonate is the predominant species, but higher pH level carbonate ion is the dominant species. Sure. Hello.
জি স্যার, শোনা যাচ্ছে স্যার।
Hello. There
ইয়েস
is
স্যার,
a
শোনা
power
যাচ্ছে।
failure in my locality. Yeah, I was near to finish. Okay, then I can finish here. It will take another 5 minutes. Thank you. And sorry for this disturbance. Uh, okay, I was talking about that. Actually, the PS range is important, which is. Okay, here you can see also alkalinity. Actually, the capacity of water to accept hydrogen
স্যার কথা বোঝা যাচ্ছে না স্যার, নেট ল্যাগিং করতেছে।
ions or protons is called alkalinity. I think you know. The alkalinity is important in water treatment. And here you can see the bicarbonate ion accept actually proton. Okay, first, now I am using the mobile data packages. I think it's not so good. Maybe I can stop here. And next lecture we will talk. I was just near to finish. Okay, no problem. I can stop here. We can stop here. Okay. Okay. Goodbye to everyone. We will again start in another talk in next week.
Yes, sir. Namaskar, sir.
Okay, thank you
Assalamu
for
alaikum,
your
sir.
patience and participation.